Hey, I just wanted to take a quick few minutes to update everybody on a new research method that we're using in River Falls to evaluate herbicide uptake when it comes to using adjuvants. And I think it's worth sharing here and wanted to put my screen up to talk through a few slides just because it's easier to share this information via slide versus in the field. And what you can see is we've looked at the increased herbicide uptake of using our adjuvants. In this case, it's looking at Class Act. And a lot of the time we're talking about corn sorb technology and how that really helps the increase of the herbicides or pesticide uptake. A lot of the times we focus on breaking the surface tension of that drop so we can spread that droplet, increase the surface area, then increase the absorbency of that droplet. We also have the corn sorb portion of it that really helps with the humectancy. So that lets the droplets stay wetter longer on the leaf. We've used confocal microscopy in the past to look at fluorescent dye on that leaf surface. Here on the right-hand side of the screen, you can see that lamb's quarter leaves, when partnered with Class Act, that fluorescent dye tends to be mobile in that first layer and move through that first layer of cells to then get into and through the plant. But it's always a question in our mind of, okay, that's a great story. It's a pretty picture. How much herbicide is actually getting into the plant? And this is one way that we've been using to quantify it. So this is a new method. I'm going to walk through it. There's 4 steps. It's pretty simple, but I wanted to walk through the 4 steps just so everybody's in tune with what we're actually doing. So up at River Falls, the controlled environments team puts droplets of spray solution on the leaf surfaces. So in this case, you're seeing a soybean leaf. They're taking a known amount of herbicide with adjuvant or without adjuvant and putting it on the leaf surface. That leaf then, or that plant then gets moved to the greenhouse, stays in the greenhouse for 24 hours. So that solution is on that leaf for 24 hours. After 24 hours, those leaves are collected and they're put into a vial and they're shaken in that vial to rinse off or wash off any of the ingredients, the active ingredients that were not yet absorbed into the plant leaf. After that, that rinsate or that solution is brought into the chemistry lab where it's analyzed using HPLC. That rinse water is taken, and on that step 4, you can see where the area under the curve can be calculated to get us a percentage of the active ingredient that was left on the leaf surface. So that's the process. Here we're looking at the data. So this is the first part of the data and the way that data sits. And you can see here, this is a part with maybe a lot of writing on it, but I really want to hone your eye into the amount of active ingredient remaining on the leaf surface. So in this case, we're looking at Enlist 1, so that's 2,4-D, and after that 24-hour remaining period, we can see that still 76% of that 2,4-D is still on that leaf surface by this quantification method. When we add Amsol, so that's just liquid AMS solution, we can increase the uptake of that 2,4-D significantly, slightly significantly, about 20% more uptake with the addition of AMS. When we add Class Act into the tank, however, we get that statistically significant increase in uptake. So now we only have 40% 2,4-D left remaining. That means we got 60% of that active ingredient into that leaf surface in that 24-hour period. So this is just a new way of evaluating that herbicide uptake. The other way that we looked at it is we took Enlist 1 and we started to do tank mixes with it. So in this case, we took Enlist 1, we added Roundup Power Max to it, and we did a similar type of structure in the study of adding that. So when we had Roundup, we got 23.3% of 2,4-D was still yet remaining on the leaf. So we got about 75+% into the plant. When we add Class Act, there we can see a statistical advantage of adding Class Act because we're getting more than 90% of that uptake of 2,4-D within that 24-hour period. The real main punchline here is what we see when we add the MSO, or in this case, it's StrikeLock to the tank. And there you can see we're getting 95% of that active ingredient in the 24-hour period into that leaf surface. One note I wanted to call out here is you can see Interlock doesn't really have much of a increase in uptake, but we really wouldn't expect that with the tank mix partner, because in this particular study, if you remember, we actually physically put the droplets on that leaf surface. And so there was not necessarily a need for interlock because that didn't affect the way that the droplet was uptaken. So I guess for more information, tune into your Winfield United representation. We'll be displaying more of these studies throughout the summer and also throughout the growing season.